Here are our two linear equations in two variables that we looked at in the last video. And here are some of the solutions that we found for each of those equations. Remember what a solution does. It would, when we substitute the values for the variables, and remember when we write the solutions in pairs like this, the first number is for x and the second number is for y. So if we were to substitute those values in for x and y, it would always make the left-hand side of the equation equal to the right-hand side. If I put in 1 for x and -1 for y, they both end up with -1 in the left-hand and right-hand expression. If I put in 2 and 2, likewise the same thing happens. The left side and the right side both become 2. If I put in 3 and 5, the left and right-hand side both become 5. If I put in 6 for x and 0 for y, the left side becomes 12, just as the right side is 12. So these linear equations in two variables have these solutions. There are an infinite number of solutions. We could never list them all. So what we use a picture, or what mathematicians call a graph, to express all of the solutions, to express that infinite set of solutions to these equations. So let's first graph the solution set of the linear equation in two variables, 2x plus 3y equals 12. To do that, we use a special arrangement of number lines. We have a number line representing the x value, which is placed horizontally. We have a number line representing the y value, which is placed vertically. This is called the rectangular coordinate system, sometimes called the Cartesian coordinate system, named in honor of René Descartes, a very famous mathematician and philosopher. And in order to express those solutions, we start at the center, which is sometimes called the origin. It's where the number lines both have a value of 0. The value of the number lines here is 0. And you'll notice, as we go to the right, the positive values are given for x. If we go to the left, it's the negative values for x. If we go up, it's the positive values for y. If we go down, it's the negative values for y. So to plot is what we call it. To plot these solutions on our graph paper, on our rectangular coordinate system, we start at the origin. So let's take this point 0, 4. We start at the origin. We're going to go where x is 0. Well, we stay right there. That's where x is 0. And then we're going to go where y is 4. Well, that would be going up 1, 2, 3, 4. So this is the point 0, 4. Let's plot the solution to that equation. It's the solution 6, 0. We need to add a point out here. We'll start where the center is, the origin. We'll go to where x is 6. That's going to the right 6 units. And then we'll go to where y is 0. Remember, it's always the x number first, the y number second in an ordered pair. Well, y is 0 if we stay right here. If you go up or down, you're going someplace where y is either greater than 0 or less than 0. Staying here is where y is 0. There's the point 6, 0. Let's plot the solution 3, 2. Again, start at the origin. Go to where x is 3. 1, 2, 3. Remember, the x is the horizontal. The y is the vertical. 1, 2, 3. And then where is y 2? That's up 1, 2. And if we were to plot other solutions, we would find that it appears that all those solutions make the geometric figure of a straight line. And indeed they do. So after we have plotted enough points to establish that straight line, we draw the straight line and we place an arrowhead at each end of the straight line to indicate that that line goes on indefinitely. That's the way we indicate that the solution set of this equation, this linear equation in two variables, is an infinite solution set because it goes on indefinitely. Any point on this line is a solution to that equation. If we had a magic pen that when we ran it up and down the line, there was a holographic image that showed up that showed the ordered pair, which actually there are some graphing tools that do that. Whatever that ordered pair was that was showing right there at the end of our magic pen, if we plugged it in for x and y, it would make the left side become 12, because it has to be a solution if it's on the line. So this is how we express the solution set of a linear equation in two variables. We do it by creating a graph.